This is number 27. I know we're going out of order, but to me, this is probably the one that's a little bit more difficult than the other two. All right, so here we go. Here's the picture. Let's mark some stuff up. And I like to do this in another color. So, all right, angle ABC. Angle ABC, that's this big angle right here on the left, is equal to angle ADC, which is this big one over here on the right. So those two are equal to each other, they told you. Now, they say that angle A, this one right up here, plus angle ABC, this one right here, is equal to 180. All right, so that it's kind of hard to draw on the picture that they're equal to 180, but what I'll do is I'll make one with two arcs, one with one, okay? So we just understand the one with two and the one with one, what do? They add up to 180. Or they're what? They're supplementary. Now, how do you know they're supplementary? If they tell you they add up to 180, how do you know that they're supplementary? It's a definition. Good. Okay, a lot of people forget to use that. It's the definition of supplementary angles. Okay, definition of supplementary angles says that if two angles add up to be 180 degrees, then they're supplementary. You follow me? Okay, there's a lot of little subtleties in these proofs that you have to catch, and you got to pay attention and you got to hear them. All right. So let's do a statement reason thing. 2 columns, since these are 2-column proofs. All right. Statement reasons. Okay. First thing I'm going to say is this: is angle A plus angle ABC equals 180 degrees. Chris, is that you with the whistling or whispering or whatever you're doing? It's really bugging me a little bit. All right, let's take a look. Angle A plus this angle right here is 180 degrees. What we're trying to do, let's go. Remember I said the road map thing and I completely got off of that. I started driving, didn't I, before I knew where I was going. So let's take a look. So we want to prove that AB, this one right here, and DC, this one right here, are parallel to each other. Now, in order for them to be parallel, watch. This line right here, let's see, yeah, this one and this one. This would be a transversal, wouldn't it? Do you see that? I'll just put a little dotted line there just to make it emphasize a little more. Do you see that line right there? That would be a transversal of AB and CD. If that was a transversal, if, we don't know yet, but if this angle and this angle were what? Not equal, but what? What do you think? Then the lines would be parallel. What? Say it. Did you say it? Equal to what? 180. Okay, give me a word though. What word did we use in? Yeah, we used supplementary in our theorem, didn't we? If this angle and this angle are supplementary, then what must be true about this side and this side right here? They got to be what? They got to be parallel. Do you see that? So if I have two lines, are you looking? This line right here and this line right here. If those two lines are cut by a transversal and the consecutive interior angles are supplementary, then the lines would be what? Parallel. So what do I have to do? I got to show that this angle and this angle right here are supplementary. Well, I don't know that right now though, do I? I know that this one and this one add up to 180, right? You could do this a couple ways. This is how I chose to do it. All right, so watch this. What do I know about this big angle B and this big angle D? They're equal to each other, right? So let's put that in there. So ABC is equal to angle ADC. All right, so that's all what? It's all given. All right, now we can go from there. What we have to do is this. In order to use that theorem that says the consecutive angles are supplementary, we first have to say that they're supplementary. I know what you're thinking. You're looking at this and you're like, well, that means they're supplementary, but we have to say that they're supplementary. So just saying that these two angles add up to 180 isn't enough. We have to say that they're supplementary. All right? So actually, let's do this. Let's do this. Instead of saying, I'll take your questions in a minute. Let me just finish this up. Watch. If this angle plus this angle equals 180, and this angle right here and this angle were the exact same thing, right? What could we do? We could replace that with this angle right there. Do you see that? So watch what I'm going to do. I'm going to go angle A plus angle what? Not ABC, but what? ADC equals 180. Now, what did I just do right there? I took that and I replaced it with something that's equal to it. What do we call that? Substitution. Good. So we write substitution. All right. Now I've got that this angle and this angle add up to 180. I still haven't said that they're supplementary. I have to say that they're supplementary in order to use that theorem. Okay? So, but now I can. If this plus this is 180, then I can say that angle A is supplementary to angle ADC. Now you look at it and people look at this and say, well, it means the same thing. Well, not technically. It kind of does, but it kind of doesn't. It doesn't say exactly the same thing. We have to use that word supplementary. Why is that? If these two angles add up to 180, why can I say that angle A and angle ADC are supplementary? Very good. It's the definition of supplementary angles. All right? I'll just put supplementary, shorthanded. Everybody okay with that? That's the definition of supplementary. Now, this angle now is supplementary to this, so they're consecutive interior angles, aren't they? Just by looking at them, they're consecutive interior angles. Now we establish that they're supplementary. What can I now say about these two lines? Now I can say those two lines are parallel. So now I can say that AB is parallel to CD, and that's my proof right there. Okay. Oh, what's my reason? Consecutive. That's right. Interior angles are what? Not equal, but supplementary. That's right. Now remember what the proof really says. It says if two lines are cut by a transversal and the consecutive interior angles are supplementary, then the lines are parallel. But man, that's a lot to write, isn't it? So we shorthand it and we just write this. We just kind of figure we know what we're talking about just writing this. Okay, listen.
Why did they do the equal sign, that little squiggly line on the top?
It means congruent. It means the same. Basically, it means the same thing. Equal sign with the squiggly. It just means congruent. In geometry, they love to use congruent. I don't really care. As far as like they say that angle ABC is congruent. There's a little subtle difference between congruent and just equals. I'm not really caring right now. Don't leave just yet. I got to give you a worksheet. Okay, and I will take those proofs from you. Yeah.